So let's take a look at the first example. What we want to first do is go ahead and plot the ordered pair, which says I'm going to go forward 4 units, and we're going to go up down 1 unit. So we have a triangle that looks roughly like this. Does it have to be drawn perfectly to scale? Absolutely not. But what I'd like you to do is get in the habit of labeling each side of the triangle with the ordered pair numbers that they gave you here. So I'm going to put 4 on the x piece, the horizontal part, and on the vertical piece I'm going to put -1. And at this point, if we're going to write all 6 trig ratios, we're just going to go ahead and do the Pythagorean theorem using those 2 numbers. So we're going to do 4 squared plus -1 squared equals x squared, or the hypotenuse squared. So we'll get 16 and 1, which gives us 17 equals x squared. And when we square root that, that will represent the length of the hypotenuse. Okay, so in this particular case, the hypotenuse had a radical, but this question at the top that asks, will the hypotenuse always be a radical? The answer to that is no, and the triples that we talked about earlier are a good example of that. The one thing you should recognize, though, is even though the x and y pieces, like the 4 and the -1, those could have negative values on them, the hypotenuse will always be positive. And so as we do Pythagorean theorem, even if it's a downward movement, like this square root of 17 looks like it's moving down from the origin, you still label that as a positive value. All right, so once you get your triangle set up, I like to put theta here in the middle, so I know that I'm always starting from the angle that's located nearest the origin. So if I'm going to write a sine ratio, we're looking at the opposite and the hypotenuse. So that's going to be -1 over the square root of 17, but we don't want radicals in the denominator, so we're going to get a negative square root of 17 over 17 when we simplify. All right, now when I go to take the reciprocal of that, I'm going to use the reciprocal of the original answer, and that way this answer will look a little bit smoother when I take the reciprocal. So we're going to have a negative square root of 17 over 1, but I like to bring the negative out front because it's better notation. You just don't want to leave negatives in the denominator. All right, now for the cosine ratio, cosine we're going to use adjacent over hypotenuse. So we're going to get 4 over the square root of 17. But when we rationalize that, we'll get 4 square roots of 17 over 17. And then when we take the reciprocal, again, I'm going to use the original function, or the original solution, to make this look a little cleaner. As far as tangent goes, we're going to do opposite and adjacent. So the opposite side was -1. The adjacent side was 4. And when we go to flip that, we're going to get 4 over -1, but again, clean that up, bring the negative out front, and there's your simplified solution.